Okay, so we've looked at the notes. We know we kind of have this guideline for finding the slope at tangent lines, and I'm gonna work through several examples here. Um, I've got this function g of x, so we're going to use this limit process that's on the other side there to find the slopes of the functions at the specified points. Now this is a point because 3 to the second power is 9, 4 times 3 is 12, and 9 minus 12 is negative 3. So 3, negative 3 is a point on there. So at that specific point, what is the slope of the tangent line of g of x? Alright, so the first thing we'll do is I'm going to just write that out, that we're going to go to the limit as h approaches 0 of g of x. Alright, g of x plus h minus g of x over h. Well, in this case, x is going to be 3. So we're talking about when x is 3. So g of 3 plus h minus g of 3 over h. Okay, well, let's plug these things into the function values, and I tend to do this. Forget to write the limit each time. Let me get that in there. Limit as h approaches 0 of g of 3 plus h. So I'm going to take 3 squared minus 4 times 3 whoops. Okay, I don't have room anyway, so let me come down here. That's 3 plus h. So it's the limit of h as h approaches 0. So g of 3 plus h. Let's put 3 plus h squared. That 3 plus h is going in for x, minus 4 times 3 plus h. Okay, there's g of 3 plus h. And then we're going to subtract 3 squared minus 4 times 3. That's g of 3. Here's g of 3. Here's g of 3 plus h. So this minus this. And that is over h. Alright, let's take a look. And I'll just come down here. The limit as h approaches 0, 3 plus h squared. That's 3 times 3 is 9, plus 2 times 3 times h, which is 6h. Foil it out if you don't remember that pattern, but I'm going to use that pattern. Just foil that out. That's what I'm doing right now. And plus h squared. I'm going to distribute here. Negative 4 times 3 is negative 12. Negative 4 times h is negative 4h. And then minus 3 squared, which is minus 9, and minus 12, that's plus 12 here. Okay, and that's over h. And then that limit, as h approaches 0, we're going to cancel out that 9 and that negative 9. Cancel out this negative 12 and positive 12. And I've got an h squared. And then 6h minus 4h is positive 2h. And that's still over h here. And it looks like we can factor a little bit. The limit as h approaches 0, if I take h times h plus 2, I have factored that, and those will cancel. So that is equal to the limit as h approaches 0 of h plus 2. And now I think we can do a direct substitution in here and put 0 in where h is. That's 0 plus 2. So the answer is 2. So the slope of the tangent line of x squared minus 4x at 3, negative 3 is 2. Okay. My next example. f of x be 3x minus 1. And what is the slope of that function at -1, -4? Alright, so we need, again, we've got to find the limit as h approaches 0. I'm just going to write that out for a little bit here until we get the hang of it. F of x plus h, this is like the y2 minus the y1 over x2 minus x1, which is just plain old h. And f of x is 3x minus 1. So we're going to take this part, that's 3. I'm going to write the limit in here before I forget. 3 times x plus h minus 1 minus, and then 3x minus 1, that's what f of x is equal, over h. And that is the limit as h approaches 0 of, what do we got? 3x plus 3h, distribute, we got the minus 1 here, and then the minus 3x here, and a double -1 is plus 1 here, and that is over h. So, start the limit as h approaches 0. The 3x cancels with the -3x. The -1 and +1 cancel out. Oops. Of 3h over h. Okay. I got it written down correctly eventually here. Those cancel out, so the limit as h approaches 0 of 3, if I substitute, there's no h to put in, that's plain old simple 3. And I'm wondering if that makes complete sense to you. Y equals mx plus b. The m is 3. So I think regardless of what point is on the line, we'd always have that constant slope of 3. So in a linear function, the slope of the tangent line is always the slope of the line, period. All right. Next, I think I'm going to save for the next video.